In this presentation, I want to go over some more graphing as we do items in Chapter 6. Again, this is early for some and appropriate for others, but want you to include it in your video lecture booklets. And what we see here, as we look at this is the point slope form of the linear equation. Now the question, and I saw this recently on an example, is here is, in a sense, the point slope equation filled in. So what they're asking us here is, what is the ordered pair, the original ordered pair that was the point that went into this equation? And what was the slope? Well, the slope is pretty easy because we look at where the m would be, and that's 1/3. Now, students often will say, well, your x point is -3. We'll just put that there, -3. And your y value is 4. But think of it, if it was a -3 and you put a -3 in there, x is -3, it's going to be opposite of a -3 would make it a +3, and that's not a +3 there, that's a -3. So my question is, what would it have had to have been, I don't know what kind of tense that is, in order for this to end up as a -3? Well, the shortcut answer is the opposite sign of what is there. So this would be a +3 then, because if we put a +3 here, it ends up being a -3. So how about this one? What was this sign originally here? What value of y would be here? We know this is going to be a 3 now. What value of y would give, as we put it in there, a +4? Because if we put a +4 there, that's going to be a -4, and it's not. Again, the shortcut is opposite sign. So this is going to be a -4. So if we put a -4 there, the opposite of a -4 makes it a 4. And the opposite of a -3 makes it a +3. Okay, so you have to be careful about that, because this is one of the kinds of questions you're going to get. They'll give it to you in point slope form. They'll say, what was the point? Remember, it's the opposite sign. That was the point. Now they want you to graph it. And I'll just sketch it for you. So you can use this point right here. So this is 3, -4. So let's do that. 1, 2, 3. And then 1, 2, 3, 4. So you're going to put a dot right there. Now, what is your slope? Your slope is a +1/3. And remember, this relationship is y units to x units for slope. And it's positive, so I'm going to have to go over from this point 3 places. 1, I do this mentally, and then I go up 1. So you'll put that on the first slide, and then you're going to have to sort of remember where that is, then go over 3, and then up 1, and put that second point there, and then the line forms. And you end up with something like that. Now they also ask sometimes, what is the domain of this? and what is the range of it. Now remember, domain are your x elements, and this will go to negative infinity. This continues all the way out here, and this will go all the way out there to positive infinity. And remember, infinity always has parentheses. And what will the range be? That'll be your y elements. Well, this line eventually will go all the way up there and all the way down there, so that's also negative infinity to positive infinity. But they don't want that, actually. They didn't ask for it in, well, sort of in interval notation, but there's another little box out here that says all real numbers. And that's the box you check for both of these. All real numbers. Now, if you had this on your blue sheet, and of course the answer is all real numbers, that's what this expresses here, they counted it wrong because you didn't do it this way. You wrote it this way. Well, of course, I'm going to give you lots of credit, partial credit for this. Full credit for this, almost full credit for this. And again, keep in mind this part. Now, another kind of example, and I want you to write this in your booklets as well, will be this. And let's write it up here. 2x is greater than or equal to 8y minus 16. Now, I want to solve this inequality for y. I want to see y is positive, too. It is positive here. So I'm going to transpose this part and go 2x plus 16 is greater than or equal to 8y. Just taking this term, transposing it, just change the sign. Now to solve for y, I'm going to divide everything by 8. Now, so you don't get confused, y generally should be written over here on the left. So again, I'm going to cancel this out. That's going to be y. So I'm going to write it on the left here. Y, a positive y. Now notice the inequality sign. The point is toward the y. So I'm going to do the point toward the y. And now I have 2/8, which I'm going to reduce to 1/4 x plus 2. Now that I have it in slope-intercept, I can easily graph that. But they want us to have ordered pairs to graph it. So now that we have this equation, I'm going to raise it up a little bit here. If I can here, let's see if I can do that here. Yes. I left my work there, but I'm going to raise it up a little bit here. There we go. Now, one of the items they ask us to do first here is, for this inequality in graphs, what kind of line do we use? Well, if it's less than or equal to, we use a solid line. If it were only less than or greater than, without the equal to, we would use a dashed line. It's highlight that. Now, we want to get some ordered pairs. Well, remember, we'd probably have to make a little t-chart here. And one is always the y-intercept because there's our y-intercept there. So if x is 0, y is going to be 2. And if x is 4, notice what happens here. If x is 4, the 4's will cancel out, and we get 1 plus 2 is 3. So there's a nice ordered pair. 0, 2, and then that'll appear as 0, 2 right there. And then 4, 3, 4, 3. So 1, 2, 3, 4, and then 3 up from here. Remember, it's from the origin. And it's, again, you could plot it. It's going to have a run of 4. So there's my run of 4, a mentally placed dot there, and then a rise of 1. But you have to put these in somehow. 1 there, and then 1 there. But actually, putting this here, these points actually form. And then we get our solid line. Not making that too well, but it's approximately that. And then they ask you here, and I've cut it off a little bit, which region do you wish to shade? And they're going to have it A up here, or I should say B up here, and A down here. Now you could do a trial point, which is what we often suggest, but if you follow that recipe I've said, if you have a positive y, and the inequality sign is less, y is less, then you shade underneath. And that's it. Okay, now I'm going to clear this up so you can see it. You can always go back, remember, because what I did is I think I saved this here. There you go. So it's a solid line, and this is the y-intercept. This is just one other point that made the graph, and we're shading A, the underneath, because a positive y is less. That's always going to be underneath. Okay, now we have one more to do. And it's this one here. I don't want to make this too long. We're going to speed it up anyway. I find that works out very well. Here they're asking us to plot the x and y intercepts. This equation's in standard form. So I'm always going to suggest that when you have that, you make an x and y intercept t-chart. And this is what the x and y intercept t-chart looks like. You put a 0 under the x, and then skip a spot and go 0 under the y. This will be your y-intercept. This will be your x-intercept. So if x is 0, y is going to be a negative 9/4. And if y is 0, this is a 0, x is going to be a negative 9/2. So, these are normally perhaps not the way you would do it, but this is a good technique because they want you to put the x-intercept and the y-intercept as answers. Let's take a look at that here. And there they are, right there. There's your y-intercept, 0 and a negative 9/4, and your x-intercept, a negative 9/2. By putting these points in, it plots it for you. So a very good technique, and hopefully this is helpful.